Good morning and welcome to Chapter 9, Trigonometry. Some of you may remember this from geometry. You might have enjoyed it in geometry. Right triangle trig is can sometimes be fun. So we're going to review right triangle trigonometry. So a couple of things that we need to review. One is we will use Pythagorean theorem a lot. Remember Pythagorean's theorem. Says a squared plus b squared equals c squared. All right, another thing we're going to use a lot is SOHCAHTOA. Remember, that's the word you used to remember the relationship between sine, cosine, and tangent. So if I have an angle, a lot of times we use the symbol theta. If I have the angle, I would say the sine of the angle is the opposite side over the hypotenuse. Am I drawing up here? C is the hypotenuse. According to theta, A would be the opposite side and B would be what we call the adjacent side. In this triangle up here, the cosine of theta would be the adjacent over the hypotenuse, and the tangent of theta is defined to be the opposite over the adjacent side. Now, that's where these words come in. S stands for opposite over hypotenuse. Cosine stands for adjacent over hypotenuse. T stands for tangent, opposite over adjacent. If I look at my triangle here, the opposite over the adjacent would be A over C. The adjacent over the hypotenuse here would be B over C. And the tangent would be A over B. All right, there's three other trig functions that we should know. And we should know cosecant of theta, secant of theta, and cotangent of theta. All right, cosecant is what that stands for, secant, and cotangent. Cosecant is 1 over sine or hypotenuse over opposite, which in this case would be C over A. Secant is 1 over cosine, which would be hypotenuse over adjacent, and in this case C over B. Hypotenuse here was, you ever see? Yeah, that's right, I did it all right. All right, cotangent is 1 over tangent, and that is adjacent over opposite. In this case would be B over A. All right, couple of things I want you to think about. We commonly use two special right triangles in trigonometry, and that's the 30, 60, 90 and 45, 45, 90 triangle. And in your note packet, there's a chart that shows how to find the sine, cosine, tangent, cosecant, secant, and cotangent of those two triangles. I want to go over that whenever you're finding the cosecant and secants and things like that, that we usually leave our answers in simplified radical form and don't change it to a fraction, to a decimal, unless we are asked to. So let's look at the 30, 60, 90 degree triangle. So if you remember that from your geometry days, if this is the 30 degree angle right here, because it's opposite the short side, This is the 60-degree angle here because it's opposite the longer side. This if we say that that has length 1, then this side has length square root of 3, and the hypotenuse has length 2. So if I was going to calculate the sine, cosine, and tangent for all of these, sine being opposite over hypotenuse would be 1/2, cosine would be square root of 3 over 2, and tangent would be 1 over square root of 3. This is where we need to remember to rationalize the denominator. And remember what that means. Multiply the top and bottom by the square root of 3. So my answer would be square root of 3 over 3. All right, cosecant is just the inverse of this, so I get 2 over 1. Secant would be 2 over square root of 3. And again, I would have to rationalize that denominator. So I would get 2 square roots of 3 over 3. And cotangent would be square root of 3 over 1, which is just 1. All right, similar thing happens with the 45, 45, 90-degree triangle, and I'll let you look at that on your note sheet and be familiar with the values for 45-degree tangent functions. All right, if you're given a triangle, you should be able to calculate all 6 trigonometric functions. You may need to use Pythagorean theorem to find the missing side first, and then you can calculate the angles. So for example, in your note sheet, you have this problem. And you're asked to calculate the 6 trig functions. All right, so I'm going to want to use Pythagorean theorem here to figure out what the hypotenuse is. So we get 64 plus 225 equals c squared. So we get 289 equals c squared. If we take the square root of that, we get 17. All right, so this is the 8, 15, 17 triangle. So now I can go ahead and find the sine of theta, cosine of theta, tangent theta. The sine would be opposite over hypotenuse, 15 over 17. Cosine would be adjacent over hypotenuse. And tangent would be opposite over adjacent. Okay, then you can just leave your answers like that. Cosecant, secant, and cotangent of those angles would be 17 over 15, just the reciprocals of these, 17 over 8, and 15 over 8. All right, what if I gave you a trigonometric expression and asked you to go ahead and find the other 6 functions? You can do that also. I just suggest that you draw a picture. So look at number 4 on your packet. If I'm given the sine of theta is 3 over 19, I want to draw myself a picture, 3, 19, and find again that third side. So I could set up Pythagorean theorem to say 3 squared plus c squared equals 19 squared. 9 plus c squared equals, what's 19 squared? 361. So c squared equals 361 minus 9. And then if I take the square root of that, trying to find my square root button, I get 18. So 352. So if I take the square root, I get 18.7 over we'll go 18.8, okay? So then I could go ahead and find my trigonometric functions here. I could say the sine of, I know what the sine is, but now I could find cosine is 18.8 over 19. We're saying theta is here. Tangent of theta here would be 3 over 18.8, and then I could go ahead and find my inverse ones as well. All right. You should know how to find a missing side and how to find a missing angle. All right, so find a missing side. When you can't do it with the Pythagorean theorem. All right, so that might mean that they only give you one side. So Pythagorean theorem, as long as I give you two sides, you can find the missing side length. But if they only give you one side, you cannot find the missing side length, and so you need to use trigonometry. So if we look at example 5, all right, so we can set up, we have if we look here, we have the adjacent side and we have the hypotenuse. All right, so the trig function we want to use here is cosine, because cosine is adjacent over hypotenuse. So I can say that the cosine of 30 degrees is x over 16. If I multiply both sides by that, I can say 16 times the cosine of 30 equals x. Now you can go to your chart and go ahead and get the fraction for cosine of 30, because that's in our 30, 60, 90 degree triangle. But I'm going to go ahead and just calculate 30 on my calculator. An important thing, if you're using your TI calculator, in the upper right hand corner of your calculator, everybody stop and take out their calculator and look. That word in the upper right hand corner has to say degree. If it says rad, R-A-D, you are not going to get the right answer. So you need to change that by clicking on it and changing it to degrees. We will talk about rad, which stands for radians, later this chapter, but right now make sure that's in degrees so that you get the right answer. I'm using my phone calculator right here because I actually don't have my own personal TI. All right, so I'm going to do the cosine of 30 degrees. When we do that, try not to round until the very end, but if you have to round, go out to at least 4 decimal places. But here, if I did the cosine of 30 times it by 16, I got 13.86, okay? So the missing side here would have been 13.86. All right, how about finding the missing angle? To find the missing angle, we are going to use our inverse functions. All right, so these are, if you're using a side, you want to use sine -1, meaning inverse. Remember, this means inverse. It is also called the arc sine. Sometimes you'll see that on old calculators. The cosine of -1, which is arc cosine. The tangent of -1, which is arc tangent. And then you can do the same thing for your reciprocal ones. Okay, so when you use these when you're trying to find a missing angle and you know the sides. All right, so I'm going to give you an example of one of those. So say I have this triangle, I'm trying to find this angle, and I know that this side is 11.9, and I know this side is 10. All right, the first thing I'm going to want to do here is figure out what trig function to use. So if I look at theta here, I have the opposite side and I have the adjacent side. Thinking of SOHCAHTOA, opposite over adjacent is tangent. So I want to find that, so I know the tangent of theta here is 11.9 over 10. All right, so to get theta, and to get theta all alone, I want to use this tangent inverse. So theta equals tan inverse of 11.9 over 10. So when you're using these functions, you're plugging in a length here. All right, when you're using this function here, you're plugging in an angle. So the regular trig functions, you plug in an angle. The inverse trig functions, you plug in a length to get the angle. So your calculator has that button. You might have to, you should make sure you know where to find it. So if I do 11.9 divided by 10, and then I plug that in to change it to -1, I get theta equals 49.96 degrees. Okay. All right, that is a basic review of trig functions. If you need more, there's lots of good videos on Khan Academy, on YouTube, so you may go and find those. You have a worksheet to complete, just practicing finding the angle and finding the missing side lengths.